Alright, boys and girls, welcome to video lesson 2-1. 2-1, our video lesson on transformations of quadratic functions. Alright, go ahead and take a moment and read the learning targets, listen to the lovely music, and read these learning targets. Okay, when you're looking at the graph of a quadratic function, okay, a quadratic function is going to have an x squared in it somewhere. It's going to have a squared term. Okay, we know that if there is not a squared term, we're going to have a line. It's a linear function, y equals mx plus b. These are quadratic functions. Quadratic functions, they have an x squared. The graph of a quadratic function is a parabola. So this blue thing right here, this U-shaped thing, this is a parabola. Parts of the parabola you need to know is the vertex, that's this point down here that turns around. The axis of symmetry is this colored line right here. It's the line, the vertical line that runs through the vertex, and it's the mirror image, so the parabola is a mirror image on either side of the axis of symmetry. More words you need to know, and you should know these words by now, are zeros, roots, or x-intercepts. These all mean the same thing. These are the points where the graph passes through the x-axis, my x-intercepts, right? So these are the points that pass through the x-axis. These are also called roots or zeros, okay? One more point you should also know is the y-intercept. The y-intercept. Okay, the vertex form of a quadratic function, the vertex form, and we'll learn some other forms later, is f of x, or y. Remember, f of x just means y. F of x is equal to a times x minus h squared plus k. We see the squared part. It's a quadratic, okay? The a indicates our vertical stretch or compression. The bigger a is, the taller my parabola is. If a is a fraction, the shorter my parabola is, and if a is positive, my parabola is going to be upside down, and if a is negative, my parabola is going to be, oh, did I say that backwards? I'm sorry. If a is positive, my parabola is right side up, and if a is negative, my parabola is upside down, okay, because the a also tells us the reflection over the x-axis. Our h indicates our horizontal shift, so it moves the parabola left and right. K is our vertical shift, so it moves our parabola up and down, which then means now the vertex of my parabola is going to be at the ordered pair h comma k. So to summarize, quadratic function in AHK form or vertex form is y equals a times x minus h. Ooh, I forgot the squared. Let me get a marker. Squared plus k. Okay, where a, and you make sure you get these into your notes, a is the direction of the width of the parabola, and the direction meaning is it up or is it down? The h is the horizontal shift, and the k is the vertical shift, and h comma k now is the vertex. Okay, looking at this problem right here, we're going to write a rule for g of x described by the transformations of the graph f of x. F of x is equal to x squared. So that's your basic quadratic function. That's going to look like this, right? Here's our graph. Our basic quadratic function, our basic y equals x squared, is a parabola whose vertex is at the origin at 0, 0. And it goes up like that. So we're going to write a function for g of x. G of x is going to equal a times x minus h squared plus k. So what I'm going to do now, I'm going to read my problem carefully here. Read it carefully. I have a vertical stretch by a factor of 2. So my parabola is going to be stretched out by a factor of 2. So in other words, it's going to become twice as tall, which means now my a is going to equal possibly 2. But it also now has a reflection. It says it has a reflection over the x-axis, which means my a is negative. So my parabola is actually going to go upside down like this, right? So my parabola, let me get my markers back, is going to go upside down, and it's going to be stretched by a factor of 2. And my a is no longer positive 2, it's negative 2. reading carefully now, there is nothing mentioned of a horizontal shift. There is no horizontal shift here, so my h just must be 0. And then my k, I have a translation of 3 units down, so my entire graph is just going to go down 3 units, so it's going to be down here like this now, okay, which means my k must be -3 because my whole graph went down 3. So when I'm all said and done, my function is going to be g of x is equal to a, my a is -2, times x minus 0, h is 0, so this is just x squared, and k is -3. So g of x is equal to -2x squared minus 3. All right, looking at this guy right here, we have a vertical compression of 1/3, a translation of 6 units left, and a translation of 8 units up. Okay, so I know I'm going to have a y equals a times x minus h squared plus k. My a is my compression and my reflection. Well, there is no reflection, so a is positive, and it has a compression by a factor of 1/3, so a is 1/3. I'm going to move my entire graph 6 units to the left. That's my horizontal translation. So h must be -6 because my entire graph moved 6 places to the left. And my k is my vertical translation. My k is my vertical translation. This graph moved 8 up, so k is positive 8. So now I'm just going to replace. my constants, my a, h, and k, with my numbers. So y equals a is 1/3. H is -6, so be careful. X minus -6 becomes +6. And the h always looks opposite of what it is. And my k is +8. There's my equation. And we're done. Okay, you guys try this one on your own. You're going to write an equation in the form y equals a times x minus h squared plus k. Remember, I would try to solve for the a, the h, and the k first, figure out what those are. You guys try those. I'm going to listen to some music, and I shall be right back. Okay, you should have had y equals -8 x minus 1 squared minus 2. And the reason we have that, our a is -8, because I have a vertical stretch by a factor of 8, and it is reflected. It's reflected over the x-axis, which makes my a negative. Okay, I have a horizontal shift, 1 unit to the right, a translation, 1 unit to the right, which means my h is +1. And my graph also moves 2 units down. 2 units down, that's a vertical shift of -2. So h is +1, k is -2. Remember, h looks opposite because it's x minus h, x minus 1 squared, and my k is -2. Okay, describe the transformations of f of x equals x squared represented by g. In other words, we converted f of x to g. Okay, so remember f of x now. Let me get a marker. F of x is just your basic quadratic function. It looks like something like this. It's a right-side up parabola. So now looking at our g of x, our a is 3, which means this is going to be stretched out by a factor of 3. And the fact that our 3 is positive means it's still going to be right side up. And my h is not -1. My h is actually +1. My h is +1, so this is going to move 1 unit to the right. And my k, we can't see it, which means k must be 0. So k is 0. There is no vertical shift. So what's going to happen now? I'm going to move let me get a marker. I'm going to move my vertex 1 unit to the right. There is no vertical shift, and then it's stretched out by a factor of 3, so it's going to look like this. If I were to describe my transformations, I would say there is a vertical stretch by a factor of 3, and there is a horizontal translation 1 unit to the right. Okay, we're going to do the same thing with this one. Our original f of x is going to look like this. It's a regular parabola whose vertex is at the origin. I want you guys right now to look at our g. and write down the A, the H, and the K. You guys write those down, and I shall be right back. Okay, you should have written down that A is equal to negative 1/2. Our H is actually negative 3 because it's x plus 3 inside. Remember, this is x minus h. H is always opposite of what it looks like. Our H is negative 3, and our K is positive 2. That being said now, our A tells us I have a vertical compression by a factor of 1/2. So in other words, this parabola got squished a little bit shorter. And because A is negative, it's upside down. There's a reflection over the x-axis. And then in addition, I have a horizontal shift of 3 units to the left. So my vertex moved 3 units to the left. And I have a vertical shift of 2 units up. I have a vertical translation of 2 units up. So my vertex moved from 0, 0 to negative 3, 2. That's it, folks. Have a great night, and we shall see you soon.